Okay, today we are going to discuss classification of signals. Means how many types of signals are available in nature. Okay, so this classification will be done based on these many topics. So the topics, the different 8 type of topics are there by which we can do the classification. So first kind of topic in this classification is based on the number of sources. So and second is based on the number of dependent variables, and third one is based on the nature of sampling, whether the sampling is continuous or sampling is discrete, and fourth one is based on the variables. The variable is deterministic or random, and fifth one is based on the repetition. Repetition leads a signal to become a periodic. So if the same waveform is repeated many times, that means signal is becoming periodic. So if this is repeating or not repeating, this makes signal a periodic and non-periodic. So this based on repetition we can see that whether signal is periodic or not periodic. And sixth one is based on symmetry. So if signal is symmetric about the y-axis, then it is an even signal, like that. So even an odd signal we will study based on symmetry. Symmetry means symmetry of the waveform of the signal. Symmetry of the waveform of the signal is checked. If it is symmetric about y-axis, then that is even signal, and I will tell about odd signal later on. Okay, based on energy and power. So if signal is energy signal or power signal, how to identify whether signal is energy or power, this will be studied in this lecture. Okay, and lastly we will divide the signal based on causality. Causality means the origin of the signal. So here there is dependence on future is checked. Future whether it depends on the future or not. Okay, so that will also study that whether signal is causal or non-causal. Okay, very good. So let us move further. First one is classification based on the number of sources, whether signal is single channel or multi-channel. So number of channel means number of sources of the signals available. If only one sensor to record the signal is available, then that is single channel. If two sensors are available, then that is two channel. If three sensors are available, that is three channel. Okay, so channel means how many different ways the same signal is coming. Okay, so ऑडियो सिग्नल्स में आपने देखा होगा कि कहीं कहीं पे दो ऑप्शन मिलते हैं, मोनो और स्टीरियो. क्या मतलब होता है? मोनो मीन्स only one channel. Mono means one channel and stereo means two channel. So if these two recordings of audio signals are available simultaneously, then that is a stereo kind. If only one recording is available, or recording is done by only one sensor, then that is mono. Okay. So you should find out the other signals also. But ECG signal can be mono, stereo, multi-channel, single channel. So what is the advantage of multi-channel? That if single channel is not, we can improve the accuracy of the result by multi-channel, and we can compare the different channels data. We can take average as the final data. So final channel signal. So that is the advantage of multi-channel. Okay. Based on the number of dependent variable, second type of classification is based on number of dependent variables. Okay. So dependent variable can be only one variable. So see, only one data. Suppose you have information available that this temperature in a city has increased from 0 to not from 0, from 27 to 42. but at what time it is increased. So what is the time? What was the time duration of for this? If this the time related any information is not available, then that is 1D signal. So in 1D only one data related to one signal is available. Okay. In the signal, data about the one dimension are only available. In the 2D, there is the data of two things, which time data and the signal at particular time. So time information is available. Then that is a 2D signal. Many times people say that also 1D signal. Actually, that is a 2D signal. If the time information is available and data itself have two dimensions, then that is, for example, video. So video is a 3D, because in video time information is available and the space x and y, the information in x and y is available. So the video is 3D. Image have only information x or y. Time information is not available. So image is a 2D signal example. Video is 3D signal. Now, if I have information related to a mosquito in a room, movement of a mosquito in a room for 30 seconds. In every second, how the mosquito moved in the room, if the information is available, so the information will be for x, means the what is the location, what was the initial location. So location will be given by x, y, z, and the moving of the mosquito with respect to time. So timing information will also be available. So that is a 4D signal. Okay, so these are some examples. You can think of your own and you can write that example in the comment. Okay, very good. So you can think of 3D, 4D signals that you know, that you see in your nearby places, all around of us. Then you can write down in the comment box of this. I will evaluate. I will see that who is writing, who is thinking, that what are the signals available, practical signals available in nearby to us. You can think of them and identify whether that is 1D, 2D, 3D, 4D or whatever dimension it have. So just identify. Like you can write in the comment ECG signal. If someone writes ECG signal, he should write ECG signal, and then he should write that this is a 2D signal. Why? Because the time, the movement of the amplitude with respect to time is available in this signal. So this is a 2D signal. Okay, good. Next one is based on nature of sampling. Nature of sampling. Sampling is always any signal is available because of the sampling only. If the signal, the sampling of the signal, if it is a continuous in the time, if it is continuously observing the data of the signal, then that is a continuous signal. Okay, or analog signal. If data is not measured continuously, if it is taken at certain intervals, then that is a discrete in time. Also discrete in amplitude, and because amplitude is also not continuous, so you can see that this is a discrete signal. Digital signal is having coding also in addition to the sampling. So this one is coded as 1 or 0. For example, if this is a 1, then next sample was here, which was 0, so this becomes 0, and after that again it becomes high, so 1 and 0, like that. So this 1 0 is called digital signal. This way we can divide the signals in 3 types based on sampling: analog signal or continuous signal, then discrete signal or digital signals. Okay, next kind of classification is done based on nature of variable. See, the variable means if you have signal x of t equal to sin t, So here the variable is t, and this variable is properly defined by sign, that this variation in this variable will be based on the sign of x function. So this kind of signal is called deterministic, because everything is predetermined. Or so, if xt is a random number which is not predefined, then that is called random signal. For example, here I have written the definition. A signal is a signal. A deterministic signal is a signal whose value can be predicted accurately by mathematical expression. Y equal to a sin omega t. This is a deterministic signal, and if it is moving some way, there is no pre-decided function or nothing pre-decided, then that is a random. So this one, this is an example whose value is very uncertain. A signal whose value is uncertain before its actual occurrence is called random signal. For example, rainfall. Anybody knows what will be the rainfall? No one knows. Actual rainfall, no one knows. So that is a random signal. That is not a deterministic signal. Anything, temperature, some natural phenomena, these all are random in nature. Maybe some deterministic by someone, but for us it is a random. Next is very important, based on repetition. Something signal, suppose it is a constant for some time, then becomes zero. After some time again it becomes on, then again becomes zero. Such kind of thing is repeated many times. So this kind of signal is called periodic, because it have a repetition period. Repetition period is called fundamental period of the signal. Because it has some fundamental period, this is a periodic signal. If the signal do not repeat its value again and again, then that is a periodic signal. Okay, periodic signals are very important. Electricity goes from a periodic signal. ECG signal is a periodic signal. Almost all things, movement of the sun, moon, earth is a periodic signal. There are a lot of signals available in our society that all are periodic in nature. Okay. See how to check whether the signal is periodic or not. You can see that if we add some time interval into the signal, then after some time interval the signal becomes the original signal again. Original information of the signal comes back again. That is the period of the signal. This time is called fundamental period of the signal. So this smallest value of this time, after which it repeats, is called fundamental period. Fundamental period of a signal is important. We will do little analysis to calculate fundamental period of any signal. Okay. Fundamental period can be calculated by this little analysis I have done. So xt, for a signal to be periodic, this xt should be equal to xt plus t. Means after this capital T time, the signal should become same. Okay, that will be equation number 1. Let us take example xt equal to a sin omega t plus theta. So equation number 2. Then adding this capital T into this, so this will become A sin omega t plus theta. So equation number 3. So we can remove this bracket, omega naught t plus omega naught capital T plus theta. Okay, so this is also equal to x of t plus capital T. This is equation number 4. Compare equation 4 with equation 1 or equation 2. For this should be the same. So omega naught t plus theta. So this is possible only when this omega naught t equal to 2 pi. This equation 2 and equation 4 are equal. These are equal if omega naught t equal to 2 pi, means at this place there should be 2 pi. 2 pi plus something is sin theta. Sin 2 pi plus theta equal to sin theta. Okay. So t will be equal to 2 pi divided by omega naught. For a signal x equal to a sin omega naught t plus theta, the time period is given by 2 pi upon omega naught. Okay, very good. Now second kind of signal that are periodic are some exponential signal with complex number. So complex exponential signals, these are e to the power j omega naught t. They are complex exponential signals. Okay, so for a periodic signal, just say xt should be equal to x of t plus t. This is a fundamental equation. So I will add capital T to this. This will become e to the power j omega naught t plus t, or j omega naught t into e to the power j omega naught t. So what we want? We want e to the power j omega naught t should be equal to 1. तो ये 1 कब होगा? जब ओमेगा नॉट t equal to 2 pi हो. Okay, so omega naught t equal to 2 pi, then t equal to 2 pi upon omega naught. This is the fundamental period of this one. Same आया, this is also same, but the way of analysis is little different. Okay, now a real practice question. The fundamental period of 50 sin 50 pi t. Sin 50 pi t is given. See this one, sin omega naught t plus theta. So omega naught 2 pi upon omega naught, 2 pi upon omega naught. So t equal to 2 pi divided by 50 pi. Pi to pi cancel. This is 1 by 25. Answer is 1 by 25. Simple. T equal to what? Equal to what? 2 pi upon omega naught. What is omega naught here? 50 pi. You can guess. Simple. Next one. Answer is C. Correct. The fundamental period of j e to the power 5t. J e to the power 5t. How to calculate this one? The time period for this one is t equal to 2 pi upon omega naught. Omega naught is 5. So this is 2 by 5 pi, means 0.4. Okay, good. Next one. Answer A is correct. fundamental period of 20 cos 2 pi t plus pi by 6. So we don't have to worry. This is a theta. Don't have to worry about it. T equal to 2 pi on omega not 2 pi upon 10 pi, that is 1 by 5. This okay? Very good. Number 5. Next, the signal sin 10 pi t into ut. See, periodic signal should be from minus infinite to plus infinite. If it is not from minus plus infinite to plus infinite, then it is a non-periodic. So when you multiply sin 10 pi t into ut, so ut is like this, and sin 10 pi t is like this. And when we multiply these two, then the resultant is the signal only running out running in the right side. Left side there is no signal. Therefore, the signal is a periodic signal. Signal is a periodic signal. So this is a non-periodic signal. So answer A is correct. अब सम की बात करते हैं. अगर हम ऐड करते हैं दो पीरियोडिक सिग्नल्स को तो क्या होता है, क्या नहीं होता है, उसके बारे में बात करते हैं. If you add two periodic signals, then the sum of two periodic signals x1t and x2t with periods t1 and t2, then sum to be periodic. If sum to be periodic, then the ratio of t1 by t2 must be a rational number. मतलब अगर आपका पहले फंडामेंटल t1 है, दूसरे का फंडामेंटल पीरियड t2 है, तो t1 बाई t2 का जो रेशियो होगा ये नंबर बटे नंबर होना चाहिए. नंबर बटे फ्रैक्शन से नहीं मिलेगा. ठीक. अब जो रिजल्ट है रेशियो उसमें नंबर्स आना चाहिए. अगर नंबर्स रेशनल नंबर नहीं आते हैं तो जो रिजल्टेंट है वो नॉन पीरियोडिक होगा. ठीक. आप देखते हैं उसको कैलकुलेशन कैसे होगा. अगर आपका पीरियोडिक आता है तो आपने क्या किया है, दोनों का रेशियो निकाला. दैट रेशियो t1 डिवाइडेड बाय t2 इज इक्वल टू a डिवाइडेड बाय b. सो यू कैन मल्टीप्लाई दिस, क्रॉस मल्टीप्लाई दिस थिंग. सो t इक्वल टू a टाइम्स t2 इज इक्वल टू b टाइम्स t1. In this way we can calculate the fundamental period. Okay. Next. Determine whether the following signals are periodic. If periodic, then find the period. First question, sin 4 pi t period, टाइम पीरियड कैलकुलेट करते हैं. कैसे आएगा? टाइम पीरियड कैलकुलेट करने के लिए आपको हमने लिखा x t इक्वल टू साइन 4 पाई टी, ओमेगा 1 इक्वल टू आया 4 पाई, t इक्वल टू 2 पाई अपॉन ओमेगा 1, तो 2 पाई अपॉन 4 पाई दैट इज 1/2 सेकेंड. तो टाइम पीरियड आ गया. दिस इज ए पीरियोडिक सिग्नल. दूसरा केस लेते हैं. एक्स टी इक्वल टू कितना है, साइन 23t है, ओमेगा नॉट इक्वल टू 23, टी इक्वल टू 2 पाई अपॉन ओमेगा नॉट, 2 पाई अपॉन 23. दिस इज ए आल्सो ए पीरियड इज दिस वन. आप थर्ड का केस आते हैं, दोनों को ऐड कर दिया है. दोनों को जब ऐड कर दिया है x1t और x2t, t1 इक्वल टू 102 है, t2 इक्वल टू 2 पाई बाई 23 है. तो दोनों का क्या हो जाएगा, अगर दोनों को एक साथ लेके आते हैं तो दोनों का होता है मल्टी to1 अपॉन t2. दोनों का रेशियो निकाल लिया. रेशियो क्या हो जाएगा 1/2 इंटू 23/2 पाई. मीन्स ये जो नंबर है वो इरेशनल है. दैट मीन्स द ओके नॉट पीरियोडिक. नेक्स्ट देखते हैं. अगर कांस्टेंट को किसी पीरियोडिक सिग्नल के साथ ऐड करते हैं, जैसे मान लो आपने 3 प्लस सम कॉस टी ऐड कर दिया, cos ओमेगा टी, तो ओमेगा टी का जो पीरियड होगा वही चलेगा, फिर ये पीरियोडिक होगा, पीरियोडिक विद पीरियड ऑफ द पीरियोडिक सिग्नल। तो यहाँ पे एग्जांपल दिया 2 + sin ओमेगा टी तो कांस्टेंट प्लस पीरियड ऑफ sin ओमेगा टी, दैट रिजल्ट इज आल्सो पीरियोडिक सिग्नल। If you add aperiodic signal to periodic signal, then resultant is also aperiodic। important है कि आपने अगर aperiodic signal, ये aperiodic है, इसको अगर आपने periodic के साथ ऐड कर दिया तो आंसर आएगा aperiodic। ठीक है, ये याद रखना, aperiodic प्लस periodic इक्वल टू aperiodic। या वेरी गुड। नेक्स्ट, अगर टाइम स्केलिंग होती है सिग्नल की, पीरियोडिक सिग्नल को अगर आप स्केल करते हैं टाइम के रिस्पेक्ट में, मान लो कि आप 2 से मल्टीप्लाई कर देते हैं तो उसका फंडामेंटल पीरियड डिवाइड बाई 2 हो जाता है। अगर आप 2 से डिवाइड कर देते हैं तो उसका जो फंडामेंटल पीरियड है वो 2t हो जाता है। ओके, so in this way we can do compression and expansion of the signal. Multiplication by of two periodic signals. Multiplication of two periodic signal is also periodic always. तो दो periodic signal का multiplication तो periodic ही होगा। दो aperiodic signals okay. Okay, we have seen this thing, time scaling, okay. This is assignment. This is assignment. Okay, so we'll stop here and you just calculate whether these are the periodic or not. Also calculate fundamental period. Okay, thank you.